10.3, number 23. R of t is position vector of a particle in the plane at time t. Find the angle between the velocity and acceleration vectors at the given value of t. Alright, so we have the position, we have to find the velocity vector and the acceleration vector at time equal to pi over 4, and then find the angle between them. There's an easy formula that I don't even think it's in the book, but the angle between is the inverse cosine of u dot v over u magnitude v magnitude. So let's start by finding our velocity vector. So v of t would be derivative of position, so it would be -2 sine ti plus cosine tj. Acceleration would be -2 cosine ti minus sine tj. So at pi over 4, we could say our velocity at pi over 4 would be the sine of pi over 2, or pi over 4 is square root of 2 over 2. I'll just do that. -2 times square root of 2 over 2 I plus the cosine of pi over 4 is the square root of 2 over 2 j. And our acceleration at pi over 4 is -2 times square root of 2 over 2 I minus square root of 2 over 2 j. Alright, so in component form, our velocity would be negative square root of 2 comma square root of 2 over 2, and our acceleration would be negative square root of 2 comma negative square root of 2 over 2. Alright, so I hope I got all those sines and cosines straight when I plugged in pi over 4. Alright, so we want to know the angle between them. We could plot those and geometrically find it, probably find use law of cosines, law of sines, that sort of thing, but we'll just use inverse cosine of u dot v. So the dot product of this velocity and acceleration would be, well, so it's the inverse cosine of u dot v, so this times that, which is 2, plus this times this, which is 2 over 4 negative, so -1/2, so 2 minus 1/2 on top, and u magnitude, v mag, so that magnitude, so the square root of that squared plus, oh boy, so square root of negative square root of 2 squared plus square root of 2 over 2 squared. So that's 2 plus 1/2 is 5/2. So square root of 5/2. And this one is going to be square root of negative square root of 2 squared plus so that's 2 plus 1/2, so that's another 5/2. So this is going to work out actually pretty nicely. So I have the inverse cosine of 3/2 divided by 5/2. So it's the inverse cosine of 3/5. Alright, so we're looking for, well, let's see, my mode is parametric, go to function, and I'll go to degree, and inverse cosine of 3/5. The angle is 53.13 degrees between the two.